Hi, good afternoon, all of you. Okay, thank you. Good afternoon. So the candidates are still coming. There is an inflow of the candidates. I just gave admission for almost all candidates who are waiting in the waiting hall. Nana, please close the door. Please close. Okay, guys. Today I'm going to explain you. We are just going to have the furthermore discussion on this statistical analysis. Many of you might not be able to understand what I'm talking in this session because you need to have. By the way, are you all able to listen to me? Am I clear? If anybody would like to talk to me, you can just write in the chat. That is the easiest way to contact me because I will try to mute all. I think it's by default all of you are muted. So in case if you would like to talk to me, just message me in chat. I will take up that for discussion. And there are 16 candidates today, right? I request Ishita. Ishita, are you there? Ishita is not there, it says. Oh. Okay, somebody have to take care of this, attendance. I don't know. I was not asked for the attendance. In case if I am asked for attendance, then I will come back to you. Okay, I'm not noting down the attendance. Somebody please have. Now, okay, so I don't know how many of you are able to follow me for this discussion. You need to have there is one essential requirement for these sessions, that is statistical knowledge on statistical techniques. You have to know all this. So in my previous session, I've explained you the summary statistics, and I also, people are just coming like that. And I think I was talking about plots. I have shown you how to make very basic plots. I had some discussion on some important parameters like color. I've shown you how to use color parameter in. So in this session, I just would like to take you to. I will try to share my screen. We'll proceed ahead with other statistical techniques. Today, I'm going to talk about key statistic, key test. And after that, I will take up the discussion ANOVA. If time permits, then I'll go for regression. In case if my session pops up, then you have to, it is not me, actually after 45 minutes, automatically session will pop up. And it simply means that the session is closed. I don't need to send you the message separately. Now let me take you straight away. These are the plots, histogram, bar plots, box plots. They're all very simple. You can just read yourself. I don't like to waste my time talking about the plots. Okay. And now for this discussion, I'm going to take up t-test for today's class. And that content is available at page number, I just keep on. I think it is page number 57. Okay. I'm straight away going there. And after that, let's see what is there at, it comes under the probability and statistics. The t-test is performed as a part of the probability and statistics. And you need to know what is the probability distribution. So every frequency distribution will be having, if you divide the frequency with respect to number of instances, then that is going to be the probability. Suppose if there are 70 female individuals and 30 male individuals, and total is 100, 70 divided by 100, which is 0.7, is going to be the probability. That is 70% of the individuals is, you are simply converting the frequency distribution into the probability distribution. That is what is a simple meaning. But in advanced level, there are, these probability distributions can be compared with the existing theoretical probability distributions. So what are they? There are quite a few probability distributions. One of the basic, very valid, the father of all probability distributions is the normal distribution. So this normal distribution is a distribution which is assumed wherever there is a normal activity. If there is some abnormality, then perhaps, there are several other versions of the normal distributions which are skewed. Chi-square distribution is a skewed normal distribution. There is a, Poisson distribution, binomial distribution. They're all, actually the Poisson distribution is not a skewed distribution. It is also normal distribution, but they're all, situational. For dichotomous data, somebody is trying to write. I didn't share. You don't need to write anything on my screen, please. I just shared the screen only to show you the text. You don't need to write there. People are trying to write with different colors. Please don't do that. You can press Ctrl Z to get rid of that. In case if you have done some writing on the screen, just please press Ctrl Z. That will get rid of that writing. Now here there is a discussion for the under probability in R. There are distributions. You see, every probability distribution in R has some, the functions, and these are the 4 default functions. There is, suppose if you have normal, suppose we are discussing about normal distribution, then there is D norm, P norm, Q norm, R norm. So these are the 4 default functions for normal distribution. And if you are, suppose we are studying, suppose there is a noise. Suppose if you are studying Poisson distribution, then these 4 functions will be D poise, B poise, P poise, Q poise, R poise. Suppose we are studying binomial distribution, then these functions will be D binorm, P binorm, Q binorm, R binorm, something like that. There is Chandrika. Just now I allowed Chandrika to the session. Now, so like this, for every distribution, like, so suppose if you have uniform distribution, UNIF, we call it as UNIF, and the functions will be D UNIF, P UNIF, Q UNIF, R UNIF. Now, what are these functions? Whenever we mention D, associate D with that respective probability distribution, then we are trying to convert that value into density. See, there is a sample distribution and probability distribution. The sample distribution is whatever the values we collect from the survey. That is, suppose if you have age particulars of some 30 individuals. So this age distribution is a sample distribution. Now, when you divide that age with the total number of instances with 30, that is going to be converted into percentage distribution, percentiles. which means percentage distribution. That is one kind of probability distribution. So in that fashion, you know, there are other probability distributions. This is percentage distribution, in which, in the same sense, we have probability distributions like normal distribution, binomial distribution, Poisson distribution, everything. So irrespective of the type of the distribution, you are going to have the functions. And these are some of the functions. You should know how to use these functions for each and every probability distribution. If it is a normal distribution, d norm will give you the density. D stands for the density. P stands for the probability. So that is actually, whenever you use P along with the name of the distribution, suppose P norm, then, pardon? You don't need to talk. See, if you are talking, actually you are disturbing me. You have any questions? Guys, this is not for talking. You don't need to talk to each other. You just have to listen to me. When you are talking, you are unnecessarily, I don't know where, I think I muted everything, but still I hear some noise. I think Redmi. Right now I muted. You are not supposed to talk now. Who is this Redmi? He is creating noise. In case if you want to talk to me, you can just, yeah, that is what I'm saying. Sir, water sound is coming. It is not water sound. One guy with Redmi, it is only an assumption. I mean, I'm doubting, because that was the only candidate whose microphone was not unmuted. Anyway, that is okay. That's a very small aberration. We don't need to think much about it. When you are using P, then you are retrieving a value from CDF, cumulative distribution function. When you use D, you are computing a value from a particular distribution. These are the two types of distributions we compute for every probability distribution. If it is a normal distribution, you have PDF and CDF. PDF is probability density function. CDF is cumulative density function. Okay, the probability density function will calculate the values which, when we plot, appears like a symmetric curve. And cumulative density function is a function in which, when we substitute the sample values, it computes, it returns the values. When we plot those values, it looks like a logistic distribution, something like that. Okay. Now these are the functions which you need to know. Every probability distribution is going to have this function. Now let us see that in action, how we can make use of these functions. You just study all these things. I cannot explain you, because I mean, not that I'm not able to explain you, because I'm going to waste my time. Suppose the D norm can be used like this. Suppose you want to find, hello, please don't do this. You just have to listen to me, that's all. You don't write, don't make noise. Please press Control Z. Whoever written on the screen, please press Control Z. If you are doing this, you are disturbing me. I'm not angry, but you are doing out of curiosity. Whoever written some scribble, I mean, there are some, somebody written lines on the screen. Please press Control Z. It is not possible for others to see the text if you leave these lines on the screen. Again, you are writing. I'm telling you to press Control Z and you are still writing. See, I shared my screen not for you. It is for me. Whoever written these lines, please press Control Z. Z, Control Z, Z button, Control plus Z button. Hello. Are you all listening to me? Hello, somebody made lines on the screen. Please press Control Z. Okay, now this is how these functions are used. Okay, when you are using denorm, you need to put the actual value. X is equal to 3. X is actually the sample distribution. And when you are using the p-norm, this is actually a rubbish activity. You should have some, I don't know, if you have done this out of enthusiasm, that is okay. But you have to avoid it. You know, I said Control Z is not going away when you are pressing Control Z. Who had written this? At least let me know, that enthusiastic guy. Who made these lines? I don't know how to avoid the stop sharing. President stop video and don't share, annotate. Oh, it is not going. So you just have to use the eraser. Eraser. Please use eraser. Okay, fine. I erased everything. But don't do this. I'll be wasting my time. Please don't do this. Okay, now this is how you need to use. So when you use denorm, you are just requesting a value from the probability density function, which means a probability value. Actually, we use p values whenever we do some test. So these p values are computed by using this functions, denorm, p norm, something like that. Q norm, this is quantile, quantities. And so that you don't need to be very serious about these functions. You will come to know slowly after some time. And now these are the distribution, probability distributions. There is a binomial distribution. So you can just use B, P binom, D binom, Q binom, something like that. So if you are computing the P values or densities or quantiles or random numbers, you have to use, suppose I want to request the random values of T distribution, then I have to use RT. And if I am interested in the probability values, then I have to use PT, something like that. So these are all actually the nitty-gritty of statistics, performing statistics in RStudio or R. Okay, so you see here the D density. This is actually D stands for the density. For a value x is equal to 6 with a size 10 and probability something like that. And this is actually the binom. So when you are using the binom for normal distribution, there are some. You can just use help function to know how to get the random values of normal distribution, densities, quantity, quantiles, or something like that. So this, you don't need to be serious about all these functions. You just have to know. That's all. Now we are not going to, very rarely we use. Now there are some hypotheses. Whenever you do the test, let it be t-test, jet test, or normality test, or binomial test, or whatever the test. We do f-test, kind of. There are thousands of tests in statistics. Whenever you are performing a test, you are testing a hypothesis. So you have basically you have two hypotheses. There will be null hypothesis. Till somebody's microphone is on. I don't know whose microphone is on. There's a lot of noise. Okay, everybody's, I think all microphones are muted. I still hear some noise. There is null hypothesis and there is alternative hypothesis. The null hypothesis is a unbiased statement. Unbiased statement. This is actually a standard statement. Every test will be having a standard statement, an unbiased statement. An alternative hypothesis is a biased statement. Suppose if I make a statement that there exist some differences between male and female, that is alternative hypothesis. It is biased statement. And the alternative version of that statement is going to be the null hypothesis, which means there are not any differences between male and female, something like that. And I assume that you know how to formulate the null hypothesis and alternative hypothesis, because you already studied the statistics, and I'm not going to explain. I already had some discussion in the classroom. Already I explained you what is a null hypothesis, alternative hypothesis, and I'll just go ahead. Now coming to the one sample t-test, there are different types of t-test. There is one sample t-test and two sample t-test. In two sample t-test, you have paid sample t-test and independent t-test. For one sample t-test, you will be having one single distribution, and for two sample t-test, you will be having two different data variables for testing. Now, this is actually the theory behind the one sample t-test. You just have to know the mathematical expression for this t, how to compute t value. Now, whenever you have a sample distribution, which is known as x, you have to compute the mean value for that sample distribution. Suppose if you have age and you are testing one sample t-test for, since you have one single, if you have one variable for the t-test, it is one sample t-test. And what is the name of the variable? Age. Let us assume that we are performing the t-test on one simple variable called age. Now what you need to do, you need to compute a mean value for that variable, and there will be an assumed mean. For one sample t-test, you will be comparing the mean value of that variable under study. In this case, it is age with assumed mean. And this difference will be divided by the standard error. You see, in denominator, you have an expression s divided by square root of n. This is actually the standard error. Now that whatever the value that which we compute by this ratio is referred to t value, and we compare that value with some standard t value. Okay. And if the value of this computed calculated t value is less than the standard t value, then we are actually accepting, we are not able to reject the null hypothesis. If the t value, the calculated t value is greater than the standard t value, the theoretical value of t distribution, then we can reject the null hypothesis, and by alternatively saying that we have enough evidence in support of we can reject the null hypothesis by saying that we have sufficient evidence in support of the alternative hypothesis. So that is how we take the decision. And this, whenever we take the decision, that particular statement of decision is referred to inference. We call it as inference. Now these are the mathematical, the maths behind the t-test. And now let us get into the action. How do we do that? Here there is an example for the one sample t-test. You can see, I don't know what is the, I think, suppose I go to the store, and yeah, actually he simulated the data set. The data frame is, he has taken two variables. See, in this textbook, actually a data frame is created. The name of the data frame is capt underscore crisp. We have to study. Suppose a grocery store sells 6 ounce boxes of Captain Crisp, so real. A random sample of 9 boxes were taken and 9 boxes were taken and weighted. The weight in ounces are stored in the data frame CAPT. There is a Captain Crisp. You see, I'm extremely sorry. Please don't scare me. See, if you scared me up, first of all, I am. Okay. So this is actually the name of the data frame, and inside the data frame there are two variables, weight, and you are not able to see the text here. Actually, it was created with the help of RStudio LaTeX. That is why you are not able to. That went away from the margins of the textbook. You see, there are two variables, weight and yeah, there is only one variable, I think, weight. Yeah, this is the one variable, and here you see the C operator is used to simulate this data set. See, many of you are not able to follow this lecture. That is because you need practice. I know all these things. That is why I'm just going like, so fastly. And if you are not able to follow my lecture, I know that you're not able to follow. You need to read this text. I already told Ishita to share this information. I don't know how many of you got. I'm sure that she surely must have shared this information with you. I've sent her email, and she had shared this email with you, all of you. You have to read. Okay, this is not just like marketing and HR. This subject is not like that. This subject is very critical, and your maturity level is not sufficient. That is why there is a teacher like me. I am trying to struggle to shoot the information into your brain. So if you are not helping me to, if you don't listen to me, I can't help you. So you have to listen to me. And it is very difficult to listen, because these subjects, when I teach this subject to MBA students who are bit mature compared to you, they themselves don't listen. Forget about students. I teach this subject to the faculty members. Many of them fail to understand. Their maturity levels are not sufficient. You need a special brain to understand this type of subjects. So not understanding is not your weakness. Okay, your age and maturity is not sufficient. When I teach this subject to the faculty members who have done PhDs, they don't understand. So not understanding is not your problem. You just have to listen. And after this class, you have to go back and practice. Then, now you see here in this textbook, a variable is created by using a couple of functions, and the functions are data frame and C. And this is actually not the correct way. I'm just going to simulate this in a different way. And you see here, this guy, I mean, the mean of this sample data is calculated by using the function mean, and the standard deviation is calculated by using the standard deviation. You see in Captain Crest, weight, Captain Crisp, weight. So when we supply this variable to the function mean, it creates mean, and that information is there in x underscore bar, and the s is standard deviation, and mu0 is actually this one, assumed mean. So here in this example, the assumed mean is 60. Okay, this data is around 60. That is why here the mu is assumed to be 60. Now we are comparing this sample mean with assumed mean, and the sample size is 9. Okay, now this is how we need to calculate the t value. Where do we have the sample mean? We have that in the object x bar minus mu0. The mu0 is 60. So the sample mean is the mu0, the assumed mean is deducted from the sample mean and divided by the standard error of this variable. So that is what is the calculation here. So obviously at the end of this calculation, we'll be having t value. So t value is minus 1.2. Now the problem is, you can either compare this t value with the theoretical value of t, but the easiest way is to compare the p value and take the decision, okay, by comparing it with the threshold value. Okay, now you see here we are trying to calculate the p value for this t value. There are two ways you can take the inference, which means decision. What is the decision? The difference between the assumed mean and the sample mean is not statistically significant. That is null value, which means the x bar is equal to mu naught. This x bar is equal to mu naught. We have some mean inside this sample information, and we are assuming that the null hypothesis is that this x bar is equal to mu naught, or mu naught is equal to 0. So anyway, there are many ways that you can manufacture the null hypothesis, I mean alternative hypothesis. Now you see here, let us go by how is the null hypothesis is. You see here actually the null hypothesis, yeah, here you see the null hypothesis. For one sample t-test, the null hypothesis is the mu is equal to mu naught, which means the alternative hypothesis mu is not equal to mu naught. The mu is sample mean, x bar is equal to mu naught, which means assumed mean. The alternative hypothesis x bar, the mean in our sample, is not equal to mu naught. That is alternative hypothesis. Now what happens after we compute the p value? How do you compute this? Now we need to use the pt. You know, I said there are 4 functions: dt, pt, qt, rt. Now we are using pt with the calculated t value, pt, t, for degrees of freedom n minus 1. Here n is 9. Obviously the degrees of freedom is going to be 8. So we have the p value. Now you look at the p value, it is greater than 0.05. What is this 0.05? It is 5% threshold value, I mean significance level. At 5% significance level, the threshold value is 0.05. That is 5%. Now, when you compare this, it is going to be, my time is out. At any time, my session is going to end. Okay, please become. Now, this is the p-value. When you observe the p-value, it is far beyond 0.05, which means we fail to reject the null hypothesis. So if it is below 0.05, we have sufficient evidence in support of the alternative hypothesis, which means mu is not equal to mu naught. What is the null hypothesis? Mu is equal to mu naught. So since this p-value is greater than 0.05, now we fail to reject the null hypothesis. What is the null hypothesis here? Let us go back and see, look at the null hypothesis. See here the null hypothesis. Mu is equal to mu naught. So this mean value, you see x bar, is in fact equal to 16. So that is what is the meaning. So the sample information, which means the mean value in the sample, is not statistically I mean, the difference between the sample information from the assumed information is not statistically different. So that is what is the meaning of the entire, that is how we decide, we take the inference from this t-test. So both the mean in the sample and the assumed mean are not different. The difference between these two values, mu and mu naught, is not statistically significant. So we fail to reject the null hypothesis. We don't have sufficient evidence in support of the alternative hypothesis. That is how it is going to be. Now what I do, I stop sharing this. I will share RStudio, and then we'll try to do the same activity. So I will try to, take a value, some kind of value. I simulate the data. I call it as my own data, my t data, and now I just take some value 50, maybe 60, and I add some noise. Or norm. Whenever this I discussed in the class, I'll take some let me take some 10 values, and this R norm is going to be, I'm just adding noise to a number called 60. Okay. Yeah, there is a question, sir. What is this mean cap crisp? Mean is a function. When you use this function on this variable, you are going to compute the mean. I'm just going to talk that. You see here, let me use R norm. Let's say some 10. I'll get 10 normal values. Now when you use round or norm, so this is the problem with this subject. Absolute. And now what is going to happen? I just round the values, and now multiply with 100. I'm just pushing this. You see, this is how we create a data variable. I know many of you are not able to follow this function, but this guy, okay, let me follow the way he has created. I'm sure you will not follow. I know your brain level. C, let me say 15.5, 14, 12, 13. What am I doing here? I'm using a function called C, and I'm just saving all these values in that object called my data. Okay, let me create some 10 values. I call 14.5. All these values are around 15. Let me say 16, 15.5 once again. And how many of them? 1, 2, 3, 4, 5, 6, 7. And then 8, 14, 9, say 12, 10. Now length of my data, 10, right? Now, how are we going to? I call sample, I call x bar. Now, if I call sample, I'm sure you will not follow. Mean, my data. Okay, now x underscore bar. So I am doing exactly the way it was explained in the textbook. Now assumed mean, mu underscore 0. This is going to be, so we know the assumed mean is, the data is around 50. I'm comparing this, the mean in this variable with assumed mean. Now mu underscore 0. What is the value? 15. Now, how are we going to calculate the t value? This is going to be x bar minus mu underscore 0 divided by standard deviation of my data divided by square root of n. N is length of my data. So actually, I did not create n, and here, since this is denominator, I enclose the entire mass of the denominator within the parenthesis. Now I got t. This is what is the t value. So unfortunately, we got negative value. You would have. So how do you find the probability value for the t value? Tt absolute of t. Why I use this is not used in textbook. ABS is not used in textbook because he got positive value, some 1.2, but we got minus point. So in t, you don't get t value for negative value of t. So that is why I used absolute. Now what is the degrees of freedom? Length of n minus my data. Length of data is n minus 1. Now let me press. What is the value? 0.57. Now can somebody tell me how to compare this with are we accepting null hypothesis or not? Are we accepting null hypothesis? Are we rejecting null hypothesis? Yeah, somebody please quickly, because my time is going on. I'm literally ticking on clock. Someone please. So this is the p-value. P-value is 0.57. Is it greater than point? Chandrika, you're asking again and again same question. Okay, mean. See, this capped crest is a variable which is created. Okay, when you use this method mean on that variable, you are just going to compute the mean value. So just like this, mean of my data. What do you have here? My data. So the same thing, it was done. Mean capped crisp means he is creating mean value for that variable capped crisp. So an intelligent like you should not ask this question. Yeah, accept null hypothesis. Very good. Chandrika, thank you. I'm an angry man. You have to excuse me. I'll be talking like this. I know many of you are upset with my attitude. Chandrika gave answer, accept null hypothesis. Yes, all of you have to clap her because that is the right. So here the p-value is 0.57, which is far away from 0.05 when you compare with 0.05. Yes, Karuna has clapped. Rest of you are not clapping for Chandrika. So now this p-value 0.57 is far away from 0.05, so we can't reject the null hypothesis. We are accepting the null hypothesis. Now can somebody tell me what is the null hypothesis? Okay, this section is oh my god, what happened here? Okay, don't clap. Okay, fine. Now the inference is that we cannot, we are not able to reject the null hypothesis. We are accepting the null hypothesis, which means the H naught is accepted. Mu is equal to mu naught. So the mean value of my data 14.15 is not significantly different from 15 in this sample, given some standard deviation, standard error in this sample. So we can't say, we don't have enough evidence to state that the 14.15 is statistically different. Statistically, I mean the difference between the 14.5 difference between the 14.5 and 15 is statistical. We don't have the evidence in support of the fact that the difference between 14.5 and 15 is statistically significant. Or simply you have to say the difference is not statistically significant. So that is how we conclude the t-test. And you don't need to struggle all these things. Are you all there? Hello, are you all there? Are we still on in this session? Because Okay, so now I'll just tell you the shortcut. Suppose we have data cards, right?